I'd like you and I to imagine that we are the router for a moment and we're deciding on the best way to get to some remote network. Let's call it network X. And if we're running OSPF, we have all the information for the network, we're going to tally up the cost of the paths involved and choose the shortest path. Hence, open shortest path first to choose the most effective path. Well, in doing that, that cost, or the accumulated cost to get to the destination, that's referred to as OSPF's metric. And so in this video and lab, we're going to take a look at the routing table again and focus on that field in the routing table regarding the metric for the route. So on our management PC, we've opened up a PuTTY session again to router 1, and let's go ahead and do a show IP route, and we'll just show it all. And we can hit the space bar a few times to go to the end of the output. And as we progress through these videos, on the far left, we took a look at the routing protocol code. So this route to the 10.23.0 network was learned via OSPF. OSPF, we learned in the previous video, has an administrative distance of 110. And this next field right here, after the administrative distance, after the slash, this part right here, we're at the 648 for this route, that is the metric. Now, metric is a generic term. It's also referred to in OSPF specifically as cost. How much does it cost? And because the administrative distance is the same for both of these routes to this network 10.23.0, and the metric or cost is the same, that's why this router is using both of these routes to get to that given network. If this top one, let's go ahead and change the cost here. If this top route had a cost of 55 and the bottom one had a cost of 45, this top one would no longer be used. It wouldn't even show up in the routing table. It would just use the lower cost route out gig 1/0 using R2 as its next hop. So similar to the concept of administrative distance where lower is better, the same thing with cost or the metric. Lower is considered to be a better path. And while we're here on the screen, let's take a look at a couple other routes. Here we have a RIP learned route. Here we have network 4444, a 32-bit route. And this metric for the RIP route is actually a hop count. So as R1 looks at these two routes for this network 4444, they both have an administrative distance of 120 because that's the default for the administrative distance for RIP. And then they also both have the same metric, in this case the hop count for RIP. So hop count, kind of think of it as how many routers do I have to go through to get to the destination. So if we have R1, R2, R3, R4, and R5, great. Boom, 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 boom. Let's go ahead and add some links here. And let's say these are fast Ethernet links on the right-hand side, and these are gigabit on the left-hand side. And at the bottom of R5 is the network that we're trying to reach. From R1's perspective, if it was running RIP, it would think, oh, to go this direction, it's only 2 hops. That would be the metric. And to go this direction, it would be 1, 2, 3 hops. And RIP would make the decision of going on the fast Ethernet path because it's not considering cost as part of its calculation. It's just considering hop counts, aka number of routers it has to go across. So that's what this number right here following administrative distance is. It's the metric, and that's dependent on the routing protocol. In RIP, we're using hop count, and in OSPF, which is over here, we are using the actual cost. That's the accumulated cost. So in OSPF, if each of these links were gigabit and had a cost of 1 there, 1 there, 1 there, and 1 here, OSPF would count up the cost. Okay, from R1's perspective, outbound here is 1, plus out of R2 is 1 more, plus out of R4 is 1 more, plus out of R5 is 1 more. 1, 2, 3, 4. So it would have an OSPF cost of 4 for the metric. While over here, with these links with a value of 10 on each of their egress interfaces, and for this bottom one also, let's go ahead and make that a gigabit. So it would be a cost of 1. So on this path, OSPF would say, wow, the exit here is a cost of 10 for fast Ethernet, 10 more, that's 20, plus 1 more, that's 21. So OSPF would choose the cost of 4 because it's lower cost than the cost of 21, and it would choose this path down the left. So is OSPF smarter than RIP? Yes. Does OSPF figure stuff out faster than RIP? Yes. Do most people use link state routing protocols instead of RIP? Yes, they do. So in this video and lab, we've taken a look at the routing table once again, but this time focused on that value right after the administrative distance. And that value right after the administrative distance number is the metric. For RIP, it's a hop count. For OSPF, it's cost. And when comparing two different routes that have the same network and the same administrative distance, the one with the lower cost is going to be preferred and put into the routing table. So thanks for joining me in this lab and video, and I'll see you in the next one. Meanwhile, I hope this has been informative for you, and I'd like to thank you for viewing.